This is a model aircraft I built in order to learn more about aerodynamics and different building techniques. After reading Martin Simon's book, Model Aircraft Aerodynamics, I was curious if I could apply some of the concepts I learned to real life. I decided to build a model aircraft with a 1 meter wingspan to fly as long as possible. I started the design process in XLR 5, where I could try different airfoil and wing designs in order to see which performed the best. I was also able to input different masses for the components that I had on hand. Using XLR, I was able to find the wing and tail design which maximized the CL/CD ratio, or the efficiency of the aircraft. I then moved on to Fusion 360, where I was able to take the specifications from XLR and design the actual parts for the plane. In order to maximize efficiency and learn as much as I could, I decided to use a different technique for manufacturing the parts this time, instead of just making them out of foam board. I wanted to use a hot wire cutter. So I designed one out of wood in Fusion 360. I then cut out and drilled the wood necessary for the build and assembled the hot wire cutter, which used a nickel chromium wire tensioned with a chain and some springs. I then cut out templates for the wing profile that I got from Fusion 360. I then attached the templates to a block of polyurethane foam that I had. Then I used the hot wire cutter to cut out the wing. I needed to try this out a couple times, since the first time it didn't come out quite right. The wire would either not be hot enough, or I would be moving too fast, creating voids and large bumps in the wing. However, after a couple of tries, I was able to perfect the technique, and with a bit of sanding, I got the perfect wing profile. Using exactly the same technique, I cut out the fuselage of the plane. I then marked out areas of the wing that needed to be cut out for servos, the spar, and the ailerons. A wooden spar was inserted into the wing. A carbon fiber tube would have been better, but it's very expensive. Servos were embedded into the wing in order to minimize drag. A very common technique when making these wings is to perform a carbon fiber or fiberglass layup in order to improve the structural integrity of the wing and to protect it. However, I found that wrapping the wing in very strong packing tape provides enough protection from rain and structural integrity. Using this technique instead of a composite layup is, in my opinion, much faster and easier, without sacrificing too much strength. Finally, to finish the wing, I cut out the ailerons and attached them to the servos. The wing attaches to the main fuselage using elastic bands, making it very easy to remove for transport. The tail of the plane is made out of simple foam board since, according to my research, hot wiring out a tail isn't worth the efficiency gain. Finally, after installing the battery, receiver, EMC, and motor, the plane was ready to go. Overall, I think the plane flew great. It was very controllable and very efficient. I was able to fly for 11 to 12 minutes on a small 850 mAh battery, which for a plane with a 1 meter wingspan is pretty impressive. I'm very happy with how this project turned out. I learned a lot about CFD and aerodynamic analysis, as well as how to hot wire wings out and make very efficient airplanes.